Hello everyone, my name is Aayush Rijal. Today I am presenting my ARP Network Scanner project which I am submitting to engineer Suman Shrestha. The goal of this project was to build a simple Python based tool that scans a local network subnet to find active devices by sending ARP requests and collecting their IP and MAC addresses. The network recognize like this is essential in cybersecurity and network management. It helps admins and ethical hackers quickly to map devices connected to the network, detect unauthorized devices, and monitor network activity. I used Python 3 as a programming language because it is versatile and has powerful libraries. For sending ARP packets, I chose Scapy, a Python library that lets you create manipulate network packets easily. The code was written and tested using PyCharm on Mac OS system. I ran the script mainly through the terminal. I also use regular expressions in Python to validate user input for IP ranges, ensuring the format was correct before scanning. The scan was performed on the local Wi-Fi network to simulate real subnet environments. Let me walk you through the most important part of the code. Now, let me explain this part of the code. For the first, I imported the necessary libraries. Scapy handle packet crafting and sending ARP requests. The RE module is for validating IP addresses. The CSP and datetime modules help with saving scan results and for crafting timestamp file names. Now we are going to explain this part of the code. This function print a simple banner at the program's start, giving the tool a professional and user-friendly look. Now we are going to explain this part of the code. This function validates the IP addresses input from the user. If the user forget to add the subnet marks, it automatically adds /24 by default. Then it uses a regular expression to check the format and verifies each segment is within valid range. This step ensures that the scan only runs on valid IP ranges, preventing errors. Now, let us explain this part of the code. This function performs the ARP scan. It sends ARP request to every IP in the sacrificed range and waits for replies. Devices that respond and coordinates active their IP and MAC addresses are collected. It also handles permission errors, instructing the user to run the script within admin privilege if necessary. Now, let me walk you through this part of the code. This part formats the prints the list of the active devices in a clean table. If no devices respond, it notifies the user. Now, let us explain this part of the code. This function saves the scan results into the CSV file with the timestamp file name. It makes it easier to keep records and track network changes over time. Let us explain this part of the code. This is a bit long part, so I am going to explain it right now. The main function controls the program flow. It continuously asks the user to enter an IP range, to scan, or type exit to quit. It validates input, scan the network, display devices, and offers the option to save the results. The loop allows multiple scans without restarting the program. And this is the end of the code. Now I'll demonstrate the live tool. I will run the script, enter a local subnet such as 192.168.1.0. It is very common subnet, and show the scan in progress. The terminal will display the active devices on the network. Next, I will save the scan result to CSV file and open it to show the data is organized. Finally, I will enter the invalid input to show how the program gracefully handles error by prompting the correct values. Now, let's get into the terminal point. So, in terminal, first we have to input is this ls command, and it will show all the files and projects in my computer, and we have to go to this project because this is where my script is located. And after prompting ls command, this is where this is my python command. So sudo python 3 and script.py. This is the command I have to enter, and after entering my password, the banner will show up. App new ARP Network Scanner. This banner will show, and my IP address of this network is 192.168.1.254, and it will show these two devices are connected. So I am going to save this, and the saved file will come like this. These are the save file. The recent one is, I think this is the recent one, and this is the IP address of the device that are connected, and this is the MAC address. This is the MAC address. Something error coming, and now we are going to enter the invalid IP address, such as this is 192.168.1.77. It is the invalid IP address, and this will show no devices found. This is the error, so it says no devices found. We don't need to save that. To wrap it up, the project gave me hand-on experience with how local network scanning works, particularly using ARP address resolution protocol. It wasn't just about writing code, it was about understanding how devices communicate over a network and how we can tap into that intersection to extract meaningful information. Using Python and the Scapy library, I built a lightweighted and beginner-friendly tool that can identify active devices within a local network. What I found most valuable was seeing how abstract contents from networking theory actually play out in a real environment. I now better understand how ARP request and replies functions, and how scripting can automate what would otherwise be a very technical task. Looking ahead, there is a lot of room to enhance this tool. A graphical user interface will make it even more approachable for non-technical users. Features like resolution devices names, saving scan log for comparison over time, and even adding more advanced sync capabilities like port or OS detection could turn it into a more capable utility. Thank you.